When we look up at the night sky and spot a famous shape like the Big Dipper, we usually assume we're looking at a constellation, but we aren't. In 1928, the International Astronomical Union carved the celestial sphere into 88 invisible regions. These rigid blocks are the actual constellations. What we actually look for are asterisms, unofficial connect-the-dots patterns that completely ignore those official boundaries. One of the largest and most prominent asterisms in the Northern Hemisphere is the summer triangle, a massive geometric shape that passes directly overhead during the summer months. This chart shows how the triangle is formed by borrowing the brightest star, the Alpha star, from three completely separate constellations. It pulls Vega from Lyra the harp, Altair from Aquila the eagle, and Deneb from Cygnus the swan. By tying these three bright points of light together, our brains create a comforting but entirely false illusion. We perceive them as close neighbors sitting side by side on a flat, two-dimensional ceiling above the Earth. But if you turn that flat canvas sideways, the astrophysical reality is exposed. The summer triangle is an optical illusion caused by our line of sight. In three-dimensional space, these stars share zero physical association. Two of the vertices are actually within our local galactic neighborhood. Vega sits roughly 25 light-years away from us, and Altair is even closer, at a distance of just 17 light-years. Both are hot, bright main-sequence stars, steadily burning through their core hydrogen. Altair has a rather unique quirk. It spins on its axis so fast that the star bulges outward at its equator and is physically squashed flat at its poles. Then there is the third vertex, Deneb. When you look up at the triangle from your backyard, Deneb appears to shine with roughly the same intensity as Altair, but Deneb is nowhere near the other two. It is buried deep in the galactic background, somewhere between 1,400 and 2,600 light-years away from Earth. For Deneb to punch through thousands of light-years of interstellar space and still look like a neighbor to Altair, it has to be a monster. It is a blue supergiant radiating nearly 200,000 times more energy than our Sun. It proves that our naked eyes are completely blind to true cosmic scale. Yet, if we return to our flat, earthbound perspective, we find the glowing, dusty band of the Milky Way galaxy cutting directly through the middle of the triangle. That specific visual alignment birthed a rich mythological tradition across East Asia. The legend tells of two lovers, the weaver girl, represented by Vega, and the cowherd, represented by Altair, who are permanently separated by the celestial river of the Milky Way. They are permitted to reunite just once a year. This story is kept active today through vibrant annual celebrations, like the Kixi Festival in China and Tanabata in Japan. Beyond mythology, this massive, unmissable shape served a practical function. Because its stars are bright and widely spaced, the asterism worked as a highly reliable celestial compass. Long before magnetic compasses, ancient Polynesian wayfinders used the orientation of these three stars to navigate thousands of miles across the featureless expanse of the open Pacific Ocean. By projecting recognizable patterns onto the flat canvas of the night sky, our brains transformed a random scattering of stars into a vital tool, allowing ancient civilizations to explore, trade, and survive. Fast forward to the 20th century, and that same ancient star pattern took on a critical role for modern military aviation. Before the invention of GPS or reliable electronic flight instruments, long-range United States Air Force bombers relied on this specific cluster of stars as a failsafe to plot intercontinental flight paths over oceans and polar regions. The geometry of the three stars was so distinct and so essential for acquiring a positional fix that military navigators officially dubbed it the Navigator's Triangle. And its utility extends deep into cosmic time. Because the Earth slowly wobbles on its axis in a process called axial precession, the northern celestial pole constantly shifts. Roughly 12,000 years ago, Vega sat precisely at that pole, acting as humanity's North Star. And in another 11,000 years, it will hold that title again. Astrophysics shows us that the universe is a deep, chaotic, three-dimensional void. But asterisms show us that by simply drawing a few imaginary lines between unrelated dots of light, humanity can always find its way home.